So in the last class, we have gone through an introduction about the magnetic based actuator, the overall usage of the magnetic based actuator for different applications, and then related to micro robotics. And we also discussed about the different classifications of these magnetic based micro robotic systems. Then we also had a discussion about this overall some of the key configurations of these magnetic based actuators, what are the different equations are governed with respect to these magnetic actuators. Today we will discuss about the different fabrication method for magnetic micro and nano robots, and then the incorporation of the magnetic components can be discussed. So if I try to tabulate the microfabrication capability and the magnetic components, these magnetic components are classified into three. So one is called as a kind of a coating a magnetic structure on the system. So that is active coating of magnets on the systems. Then creating a magnetic segments. Third is a magnetic particle generations. Now, when we try to talk about an active coating of magnetic systems, so let us consider we have a kind of a flexible rod. Over the flexible rod, we go for a magnetic coating, so that by applying an biasing towards the magnetic field, appropriately we can study the deflection. So as far as in this particular case is concerned, so this can be either in the form of magnetic films, or it can be in the form of bulk structures in the order of few microns. So the different techniques which are being employed for this are like an E-beam evaporation, a physical vapor deposition, in particular sputtering is used, then a dip coating system. So this is the case when we are considering a magnetic film. Similarly, when we try to consider a magnet segments, so we can have a electrode deposition, or a kind of a oblique angle deposition. So magnetic segments means part of the magnetic structures are being integrated into the system, like for example AGNI micro wires, integrated with the system, are one good examples where it is called as a magnetic segment. Okay, so it will be mixed with like for example you have a fiber, so or you have a composite structure. Along with the composite structure, such kind of structures are mixed, and then appropriately it is being used or actuated to create a certain amount of configurations, etc. So we will see those configurations now, and then when I talk about the magnetic particle based systems, so in the case of magnetic particle based systems, hydrogel robots that is magnetic particle integrated hydrogel robots are efficiently used for different applications. So that is something like, so you try to disperse the magnetic particles. So when we try to disperse the magnetic particles through a dip coating process or through an emulsion process, so we can just integrate these magnetic particles along with the hydrogel, so that when we try to actuate these magnetic particles, so appropriately there will be a deflection which exhibits over here. So it is called as a kind of a magnetic particle impregnating, etc. So let us see some case studies where they had deployed these kind of magnetic particles for efficient diffusion or efficient characteristics. So overall, if we try to look into the overall microfabrication for developing such kind of systems are concerned, so we have a photolithography in place, then a direct laser lighting, glazing angles deposition, template assisted deposition, electrode deposition, and there is a technique called biotemplate method. So these are some of the systems, these are some of the fabrication facilities which are well established for developing or integrating such kind of magnetic nanoparticle based systems to create the structures what we are looking for. Okay. Now let us discuss some different micromanipulation technique so which are being used by for actuation of different design of magnets. So like if I try to look into the magnetic magnetic micromanipulation for micro robots, it can be classified under two categories. One is the torque actuated, and other one is the force actuated. On the torque actuated perspective point of view, we have a time varying magnetic field and in the case of a force actuated, it is called as inhomogeneous magnetic fields. So let us take a propulsion in terms of rotation, where we have a magnet and there is a rotation which exists because of the movement of the magnet. That is, a magnetic field will be there, and then we can create a rotation when there is a circular structure is being propelled in this particular domain. When we try to talk about the oscillation perspective point of view, so this is a kind of a structure where it oscillates by giving an appropriate magnetic field over here. Okay. Now, if we need to have a stepping system, a magnetic field is applied in steps to create a kind of a incremental displacement. Okay. Now, when we try to talk about the field gradient, as far as field gradient perspective point of view, so we will be having a dispersed magnetic field with magnetic field applied over here with V, and these dispersed magnetic field are kind of a force actuated, which will be helpful for the overall manipulation in a particular domain. So, as far as these force actuators are concerned, these are efficiently used for different biomedical related applications. It has a potential application towards biomedical related domain. So, these are some of the basic comparison, basic classification with reference to magnetic micromanipulation for micro robotic system, and based on the manipulation capability appropriately they are classified as torque actuated and force actuated. Now, let us see some of the origami based magnetic actuator which has a potential application towards micro robotic system. So, this is a kind of an origami based actuator. So, this actuation of this origami based actuator is done by just dispersing these kind of magnetic nanoparticles inside these structures. So, what happens is, so we have a kind of a fibrous layer which is available. So, in these fibrous layer, so the magnetic particles are dispersed and then it is being encapsulated. So, it is something like this. There is a PDMS structure which is taken up. These PDMS structures are etched in this particular domain. Now, the nanoparticle with a particular domain is made to dispersed in these PDMS based structures, and then it is filled with hydrogels. So, what happens? There will be a kind of a layer of a hydrogel which will be filled over here. Now, based on the type of the shape or based on the type of the geometry what we are looking for, so appropriately a curing will be done. So, a curing is nothing but a laser will interact in this particular region, so that only that particular region will get cured and the domains of these magnetic particle will be cured in that particular portion. So, like that what happens is, so you are trying to align the domain for a particular region. So, wherever an actuation is requested, based on that a patterning is done or a kind of curing is done appropriately. So, by curing it, you get a kind of a structure what we are looking for, like for example in this case. So, this is a kind of structure on an initial phase which has a PDMS coupled with the hydrogel, and then on actuation you get a kind of a structure something like this. Similarly, if you need to have a structure, so we can have a kind of a lotus structure what we are looking for. So, this is a kind of a selective structures. So, in these selective structures what happens is the pattern are expected to be integrated in such a way that you can have a micro motion which can be a kind of an outcome of such kind of magnetic micromagnetic actuators. So, ideally if you want to if there is a need to go for a kind of a programming in the form of a origami based structure, so which is possible by this technique, since there is a flexibility of using magnetic nanoparticles. So, these magnetic nanoparticles can be easily dispersed with these hydrogels, and appropriately it will be coated on the PDMS layer and cured based on the type of shape or the actuation which the system will take up a shape. In fact, this YouTube link you can access, you can have much more idea about such kind of magnetic based nanoparticles. It is from a university and it is an open access system. Now, like, let us see some of the applications of these magnetic actuators for micro robotic applications. Apart from micro robotic applications, since it has a high potential towards a non-contact based actuation, it has a potential application in biomedical related reason. So, especially in the case of biomedical applications, these kinds of magnetic micro robots are well deployed. So, either it might be for a therapeutic related applications or it might be for a imaging related applications. So, when we try to look into the biomedical application perspective point of view of magnetic micro and nano robots, we can see different applications. Several research groups are working in this domain. Of magnetic robots. So, we can classify it for in vivo application and in vitro application. So, in vivo application perspective point of view, it is used for cancer treatment, cell therapy and tissue regeneration, thrombolysis, imaging and surgery. In the case of in vitro perspective point of view, it is used for diagnosis, and mechanobiology study. So, under the cancer treatment perspective point of view, it is used in drug delivery, controlled drug release, and drug deep penetration. And in the case of cell therapy tissue regeneration perspective point of view, it is efficiently used in delivery and differentiation, especially for stem cells, neuronal cells, etc. And thrombolysis perspective point of view, it is used in delivery and mechanical disruption. The case of delivery, it is used in tissue plasminogen activated. And in the case of imaging, it is used for delivery and MRI related applications. Especially it can be used as a kind of a fluorescent substance. Now with reference to in vitro perspective point of view, so we are classifying it under diagnostics and mechanobiology study. So in the case of diagnostics, we have the rheological study and biosensing. Especially in the case of biosensing, it is used for detecting protein, DNA, cancer cells and toxins. So these are some of the biomedical application of these magnetic micro robots. So it is used for kind of a like in many cases it can be used as a kind of a surface walker. In many cases it is also used for a kind of a rotation, and in many cases it is also used for a kind of a therapeutic applications. Now we will discuss about the next actuator, which is called as a piezoelectric actuator. So as far as these piezoelectric actuators are concerned, like these piezoelectric materials can transform the mechanical energy into electrical energy. So the piezoelectric is obtained when a specific crystal structure which must be asymmetric, that means that there is no symmetry center with regards to the positive and the negative ions. So ideally in the case of a piezoelectric actuator, like we have discussed in several forums, several lectures, where we have a kind of a crystal. So when we try to apply a load to the crystal, we get a biasing at the directions, and then when we try to apply a biasing, we can get an actuation which tries to exhibit out of it. So now the interesting part of these piezoelectric structures are these piezoelectric structures are efficiently used as an actuator as well as a sensor. So when we go back to the same magnetic based system, so the current actuation which is used a kind of a simple magnetic based structures. In addition to this, there is one more concept which is available, which is also called as magnetostructive based structures. These magnetostructive based structures are not efficiently used for micro robotic applications. However, there are wide varieties of applications with reference to different devices. So terphenol D is considered to be a standard material which is used for such kind of magnetostructive related structures and applications. Now, like when we try to go into this piezo actuator perspective point of view, like magnetostructive and piezoelectric almost it works on the same functionality. However, piezoelectric has a wider application. In fact, more than a decade people, more than 3 to 4 decades people have been working on these piezoelectric structures, since this piezoelectric material can transform the mechanical energy into an electrical energy, and this piezoelectric effect is obtained with specific crystal structure which must be asymmetric. That means there is no symmetry center with regards to the positive and the negative ion of an elementary cell. An external mechanical compression causes the positive and negative charge center of each elementary cell to separate, which leads to ionic polarization, and an electric charge is appearing on the outer surface of the crystal. Since cause the voltage applied and the effect, The change in length are strictly proportional to the additional sensor, which are not necessary. And piezo actuators are also known for a quick reaction speed, basically which we have termed it as a stimulus, and it has a reproducibility of the traveled distance. So, piezo actuators can exert quite a good amount of very high force compared to the conventionally compared to the some of the supporting smart actuators which are available. So, this is a kind of a piezo actuators which are commercially available. So, if you closely observe in these piezo actuators, these piezo actuators are stack of actuators which are being coupled and which are being efficiently used for transfer of the systems. Okay. Now, when we try to classify the type of piezoelectric actuators, the piezoelectric actuators are classified into two. One is called as a direct piezoelectric effect and the other one is called as a converse piezoelectric effect. So, the comparison between these two direct piezoelectric effect and converse piezoelectric effect will be discussed in the upcoming lecture.